Hello and welcome. This presentation is on the impact of sodium hypochlorite used for chemically enhanced backwashing for biofouling mitigation in MBR. As an introduction, in the bid to mitigate the membrane fouling challenge in MBRs, the study presents two scenarios of a laboratory membrane bioreactor, which was carried out in two phases and compares the effects of chemically enhanced backwashing on the transmembrane pressure buildup and biological performance of the membrane bioreactor. In line with the materials and methods, Table 1 presents the MBR operating conditions, and Figure 1 is a schematic representation of the laboratory scale MBR. In line with the results and discussions, a comparison of the TMP buildup between Phase 1 and 2 shows that during Phase 1, which entailed two runs 1 and runs 2. During the first run, the TMP took approximately 4 days to reach 50 kilopascals, while during the second run, the TMP took approximately 6 days to reach 50 kilopascals. And during this phase, there was no sodium hypochlorite used for chemically enhanced backwashing. During the second phase, which entailed the use of sodium hypochlorite for chemically enhanced backwashing, the third run took approximately 12 days to foul, and the fourth run took approximately 11 days to foul. A comparison of the flux size variation between both phases shows no significant difference in the two phases. A comparison of biomass and biopolymer concentration between the two phases shows that the MLSS was relatively similar in both cases, while the protein and carbohydrate EPS was higher during Phase 2 than in Phase 1. In line with the nutrient and organics removal efficiencies of both phases, TN and TP was relatively more stable during the second phase than the first phase, and the TOC and COD were relatively stable during both phases, were similar during both phases. Summarily, we can conclude that chemically enhanced backwashing substantially reduced membrane fouling in terms of the rate of TMP development during Phase 2, and flux size distribution and biomass concentration were relatively stable during both phases. EPS, proteins, and carbohydrates was relatively higher during Phase 2 due to a backflush of EPS from biofilm growing in the permeate line and the membrane surface. Nutrient removal efficiency was more stable during Phase 2, and organic removal was relatively similar during both phases. Additionally, during a previous study by Yu et al. In 2014, sodium hypochlorite was found to inactivate some bacteria in the influent flow of the permeate line and membrane, which reduced both microbial proliferation and the production of proteins and polysaccharides in the cake layer, and contributed significantly to improving the overall ultrafiltration performance. Thank you.